Hello. Once again, my name is Lukman Mohammed, and we are here to see the third assessment for our physics. Let's get started. Question 1 says, which of the following is not a fundamental SI unit? Please note, not just fundamental quantity or unit, fundamental SI unit. And we know that the units of fundamental quantities are also known as fundamental units. Mass, now meter here is a unit of length, and length is a fundamental quantity. But here we are interested in the one that is actually SI. This is meter, seconds, kilometers, amperes. Amperes is a fundamental unit. Seconds is a fundamental unit of time. Amperes is a unit of current. Meter is the unit for length. Kilometer is also the unit of length, but it is not an SI unit. Not all units of length are fundamental quantities, okay, and not all of them are SI unit as well. The standard unit for time is seconds. Time can be measured in meter and in minutes, in hours, weeks, days, months, and years. If I ask a student, when are you going to be a graduate? Maybe in 3 years' time. It is time, but it's measured in years. If it is very close, the student is a final year student and second semester, that's when I'm going to be a graduate. 2 weeks' time, 3 days' time, tomorrow, oh, in few hours, 30 seconds from now, I'll be a graduate. So, but the one that is SI unit of time is seconds, and that is also the fundamental unit for time. Let's go. Number 2 says, one of the following is a derived unit. One is a derived unit. This is Newton. That is just the answer. Let's see. Kilogram, meters, Kelvin. Kilogram is for mass, meter is for length, Kelvin absolute temperature. So Newton is the one that is not a fundamental and hence a derived unit. Question 3 says, the point beyond which a stretched spring does not return to its original length is called what? This is enshrined in Hookean law, which says that an extension produced in an elastic spring is directly proportional to the force that has brought about the extension, so long as the spring has not exceeded its limit of elasticity. So that point beyond which an elastic spring will no longer return to its original point is called the elastic limit, or the limit of elasticity. This one wants us to do a quick calculation work here. It's saying that what is the resolution of a force of 18 newtons along the horizontal? So we need the horizontal component. We could have drawn something that looks like vertical here, if you are interested in the vertical, and I've told you before that this vertical can be placed here. It's the same. You can complete this right angle triangle. So this, if you come from the triangle law or parallelogram law of addition of, you can see that this value here, what is here, is going to be what is here, and what is here. So this vertical is here, so we can be viewing it from this point. So now, what is the resolution of the force of 18 newtons along the horizontal? I told you, if this angle here, this angle 60 degrees, is pointing to this side, so long as it is opposite to it, you are going to use sine. Automatically, this is adjacent to the angle, and this is going to be cos. So this is going to be 18 cos, what is the angle? 60. What is cos 60? Cos 60 is 0.5. So 18 times 0.5. So 18 multiplied by 0.5 is 1/2. So this is going to be 9 newtons. 9 newtons. Option C is correct. Next question says, which of the following is actually a true representation of the above system of forces? This is what you should be looking out to. We are following orders. If you start, well, I'm going to start moving from P and then Q and then R. I'm going to start from each of the vectors. If I start from P, look at the arrow. It's going upward like this, so I'm following that arrow. The next place I can go to, I can't go here. The vector, nothing goes there. I can only go down to this place, but I'm going against the arrow. So it is not true that after going from P, I'm going to, this is negation. So let me start from R and see what happened. This is the direction of R, okay? And when I come to this side, if I go down, I am actually against the direction. So let me start from Q. I'm going from Q, the arrow goes that way. Okay, when I get to this place, I have to turn. Oh, I'm in line with the arrow, so that's correct. So this one that is now against them, look at Q and R, I'm going to add them together. This is against their direction, so I'm going to say they are equals to what is against their direction. So I'm going to say R, Q, I'm starting from Q now. Let me start from Q. I started from Q, and then R is also in line with the arrow plus R equals to the one that is against them. So I can write it like the P equals to Q plus, I can write it from P first. P equals to Q plus R. So let me write it that way. P, vector P equals to Q plus R. So which of these options looks like this? Do you know that I can bring all Q and R to the other side and then equate it to 0? I can say P minus Q minus R equals to 0. If I ignore this, another way of writing this, I can look at this like this. This is Q plus R. I put them in bracket like that. Then I write P. I bring this summation into the other side. So I'm going to say minus, they are going to be in their bracket, then Q plus R equals to 0. So which of the options look like that? So option A is directly this first one. So option B is not correct because I have P minus Q minus R. And then option D, P equals to, you can see, not equals to minus Q plus R. If I put this equality, if I want to rewrite this third option, it's going to be P still equals to the first one. Then going to be positive Q plus R because this minus has go to the other side, which is the same thing as 1. So option A is correct. Now, the International Agreed System of Units, they have assisted you. That's talking about SI units. So what are this is kilogram, unit of mass, meter, the unit of length, seconds, the unit of time. That's just the correct answer. Those are they are even fundamental. But let's see this. Let's try to see whether we're going to see options that look similar to them. Centimeter is not even a standard unit for length, so that option is gone. Even gram is not, but seconds is standard. Newton is a derived. Gram is not an SI unit, even as meter is an SI unit for length. Gram is not, so meter is correct, seconds is correct, but the one that have all correct agreed SI units is option A. And then question number 7 says a piece of rubber 6 centimeters long stretches by 6 millimeter, difference of units, when a load of 100 newtons hangs from its end. What is the strain on it? What is the meaning of strain? Strain is referring, okay, let me bring this description here. Let me show you this description. Assuming we have a rod that is of length, for example, 200 centimeters. The length is 200 centimeters, sorry, 200 centimeters, and then something, maybe a load. This, sorry, if this is a spring, actually, this is a spring, and then a load is attached at the end here to stretch it, and it stretches just by a little amount. This is the original length. This original length, we call this L original, L naught, and then it stretches by a few amount of maybe 6 centimeters. I'm using similar unit now. Then what is the meaning of strain? Strain, not stress now. Strain is the ratio between the extension produced by the load all over the original length. Okay, so what is the extension here? It extends by 6 centimeters divided by what is the original length. Do not call it 206. The full length now is going to be 200 plus 6, which is 206 centimeters. But the actual length is what? 200, not the new length 206. We are going to be saying 206 now. So we just fraction out the extension divided by the actual length before the extension, which is 200 centimeters. So centimeter is going to cancel centimeters. So you only have 6 divided by, when you divide this 0. Whatever you get, that is what the strain. You can see they are in the same unit. But now we are being told that here the force is 100 Newton. We don't even need that. I extend this rubber, which is of length 6 centimeter, extend it by 6 mm. So that's the extension. So what is now going to be the strain here is going to be 6 millimeter divided by 6 centimeter. There is difference of unit. How do you convert millimeter? Sorry, this is mm. So this is going to be, I'm going to multiply this by 10. It's a factor of 10 between them. We multiply millimeter by 10 to convert it to centimeter. I'm not writing the unit again because they're going to cancel. Divided by 6. Sorry, this is 6. This is not the one you multiply. This is 6 divided by 60. You multiply centimeters by 100 to convert it to millimeter, or you divide millimeter by 10 to convert it to. So when you do this division, you are going to have 0.1. No unit. Okay, so option C is the correct answer. Let's go. What is the work done when a catapult of elastic constant 300 Newton meters stretches by 30 centimeters? It is 30 centimeters, and this force constant is in standard unit, Newton per meter. You can say per meter, so I know that I cannot use this 30 centimeters. What is the relationship between centimeters and meter? You divide centimeters by 100, because 100 centimeter, 100 meters, 100 centimeters equals 1 meter. Centi is talking about 100. So if I divide this 30 by 100, I'm going to have, so the formula for work or energy is half k e squared. So half is something as 0.5, 1 all over 2 times constant is 300 multiplied by the square of extension. This 30 is now 0.3. So I'm going to square that. If you punch this into your calculator, you have 13.5 joules. Number 9 says, matter, according to the kinetic theory, asserts that there are options, Roman figure 1 to 4 here. So we want to see which combinations are correct. Okay, matter is made up of spikes. No. Matter is made up of tiny particles. This is correct. Matter, the particles are in a state of stillness. Stillness means they are static, they are not moving. Is that true? No. The particles are in a state of constant motion. Yes, they are in a state of constant motion, vibrating about their mean position if it is solid. But what matter is they are in constant motion and they are made of tiny particles. So options 2 and Roman figure 4, Roman figure 2, Roman figure 4 are correct. So which of the options says that? A, 1 and 2 only. B, 1, 2, 3 and 4. C, 2 only. Okay, option D says 2 and 4. Yes, they are made of tiny particles. They are in a state of constant motion. Okay, when a body is given a slight displacement and it returns to its original position, then it is in a state of neutral equilibrium, stable equilibrium, unstable equilibrium, disorderliness. This is not even part of it. There is nothing that has to do with disorderliness when it comes to equilibrium. Okay, so it can either be neutral. What is neutral equilibrium? When a body is being displaced, okay, and it does not move away from its original position, but it is lying in a different state. Okay, maybe something is standing before, then if it slips, it falls down. So its new position is in that place that it slips, but it does not move further away. So that is neutral equilibrium. Stable equilibrium is when you displace it and it immediately returns to the original condition and position. So that's stable. Unstable is the one that as soon as you displace it, it continues to move further away and go and rest in a different position. If you kick a ball, it will move away from the position you put it. If you put a cone seated on its base, okay, and you push the head a little and you release it and it falls back by sitting on the base, it is stable. But if you push it, okay, or you turn it upside down, okay, and then you remove your hand, it is going to fall. It's not going to stand on that pointed end again, but it does not move away. So it is what? Neutral. But if it moves away, such as letting the cone to slip on a slanted arm and you roll it, then that is unstable equilibrium. Question 11 says the resultant of a number of forces in magnitude and direction is given by R equals to 25 newtons, south 18 degrees west. What is the equilibrant of the force? We have mentioned before that equilibrant and resultant, they have the same magnitude. So we can represent it like this: resultant is equals to negative equilibrant. Please, the negative does not show minus. For example, 20 newtons, then you're going to be minus 20. No. We're going to show is equal to. Equality is showing equal in magnitude. Minus is showing opposite in direction. So if resultant is pointing up and is 20 newtons, equilibrant is going to be 20 newton as well, but it's going to be pointing down. If resultant is pointing eastward of a particular magnitude, equilibrant will be of the same magnitude but westward. So that is it. So what we need to do here is we see that resultant is 25 newtons. So equilibrant is also going to be 25 newtons. Then what's going to be the direction? This is south 18 degrees west. Okay, that is the resultant. So we are just going to change south to north for equilibrant. The opposite of south is north. Write the same 18 newton. What is the opposite of west? East. So the equilibrant is also of 25 newtons, north 18 degrees east. Where is that? North 18 degrees east. This is the correct option. C is saying 18 newton, 25 wrong, because 18 is not the magnitude. The magnitude must be 25 newtons. And the angle is also going to be the same, but north will change to south, and east will change to west, or west will change to east, and south will change to north. So option D is the correct answer. 25 newtons, north 18 degrees east. Yes, this question is saying find the magnitude of the net horizontal force acting on the particle. Please note, net horizontal force. We do not need the vertical. Another way of saying this is find the resultant along the horizontal. Resultant along the horizontal. The actual resultant of all these forces is the combination of the horizontal resultant and the vertical resultant. So I do not need to draw this vertical here. I will have resolved this 16 newtons as well on the vertical, but I don't need that. I just need the total horizontal. So I am resolving and then I'm going this way. Okay, so this is going to be 20 is going that way, 20, but 8 newton is against it, so minus 8. And then another force I can consider on the horizontal is this 16 newtons, but its resolution on the horizontal, if I complete this like this angle 30 degrees is facing the vertical, so vertical is going to be sine and horizontal is going to be cos. Okay, so this is going to be plus, and I can only resolve it to this side that I've taken as positive, plus 16 cos 30. Okay, along the horizontal. So 18 minus this, that's going to give 12, plus 16. What is cos 30? Root 3 divided by 2. So this is same thing as 8 root. This is, so what is 12 plus 8 root 3? 12 plus 8 root 3 from calculator plus 8 root 3 is 25.856. 25.856. So which is going to be the answer? Option C is saying 25.8. Option A is saying 25.9. Of course, if I approximate this, it's going to be 25.9 newtons. So option A is correct. Next is find the magnitude of the resultant of the system of forces. They didn't say horizontal resultant or net horizontal component of the resolution. They didn't say vertical resultant. The resultant, so it's going to be the combination of the horizontal and vertical resolution. So I want to resolve along this part first, or resolving along the horizontal in this direction. So I'm going to have 8 is pointing that direction, yes, but 5 is against it, minus 5. This is equals to 3 newtons. Okay, upward, I want to resolve upward. Okay, what is pointing upward? 8 is pointing upward, but 4 is pointing against that, minus 4. This is 4 newtons. So I can combine this. One is going sideways like this. Let me draw that. And what value do you have there? 3. Immediately from this, another one is going up, so I can put upward force there. That is what? 4 newtons. By saying it without even applying, I know that from Pythagoras theorem, this is a right angle triangle. 3 and 4, this side is going to be 5. The resultant is going to be 5. And if you want to apply Pythagoras, it's going to be 3 squared plus 4 squared equals to, I'm going to call this r. So if you make r the subject, r is going to be square root of 3 squared is 9, 4 squared is 16. So that's the square root 25. What's square root 25? 5 Newton. You just want us to find the magnitude. Magnitude is that number. Direction is what we give in terms of angle. Let's go. 14 says, under what condition is Hooke's law not obeyed? Go back to the statement of Hooke. It states that F equals to KE so long as extension, the spring has not exceeded its elastic limit. So they are not asking you under what condition is it obeyed. They're asking you under what condition is the Hooke's law not obeyed. So we are going to say it is when the elastic limit has been exceeded, because the law is obeyed according to Hooke when the elastic limit is not exceeded. So they're asking you when is it not obeyed. So when the limit of elasticity has been exceeded. So option D, which says when the limit of elasticity has been exceeded, is going to be the correct option. Now the last one here says the resultants and equilibrants of a system of forces are, what's going to happen to them? Exactly the same. Option A. Are they exactly the same? Option B says same in magnitude but opposite in direction. C says same in magnitude and direction. That is, they are the same. If they are 20 newtons, they're going to be 20 newtons, and they're also in the same direction. Is that true? No. Follow the same direction but different magnitude. They don't follow the same direction. Their directions are opposite. So this one that says exactly the same, in what manner? It is not specified. But B is the correct one. It says they are same in magnitude but opposite in direction. So we come to the end of the third assessment. Thank you.